Okay, right, so we are doing an application of maths past paper here. This is the paper one from 2018. The way that my videos work is I'm going to go through each question, doing the working and then showing you where the marks have come from for each question. I'll be talking through every single thing that kind of comes through my head as I'm answering it as a kind of maths teacher. Just some advice, I think it'd be a good idea to have the paper in front of you. Another good thing to do is to have a go at the question yourself first. If you get stuck, obviously keep watching. Otherwise, use the video to check where your marks have come from and that your working looks similar to mine so that you're making sure you're not missing any marks. Right, so we'll get going with question one. So we've got a baking company will reject cakes if they do not weigh 400 grams plus or minus 3%. The weights of the sample of cakes, 13 of them, are shown below. Calculate the fraction of cakes that will be rejected and use your working to justify your answer. So the place we need to start is our important part, which is this. So 400 grams plus or minus 3%. So we're going to have to work out 3% first. So 3% of 400 is where we're headed. But first to find 3%, if we find out 1%, so 1% of 400 grams, to find 1% we divide by 100, so it is 4 grams. So 3% is 3 lots of 4 grams, which is 12 grams. Right, so if we work out our maximum value, it's going to be our 400 grams plus another 12, which gives us 412 grams. And our minimum is 400 grams, take away those 12, which gives us 388 grams. Right, so we need to work out now which values will be, we can either work this out as which would be rejected or which will be kept. So I'm going to score out the ones that will be kept, so the ones that are left are the ones that would be rejected, which gives us the fraction, which gives us the numerator for a fraction, because we've been asked to calculate the fraction of cakes that will be rejected. So if we look, so we're looking to get rid of any cakes that are in between 388 grams and 412, including those. So 385, that would be rejected, so it can stay. On my list, I'm not going to score it out. 391, that would be okay, so I'm going to score it out. So would 409 and 403. 386, that's too low, so it would be rejected. 412, that's okay, so we can score it out. 413 would be rejected though. We've got 407 would be okay, so score it out. So would 400. 390 would be okay. 387, that's too low. 405, that's okay. And 388, that's okay. So we have 4 cakes that would be rejected. So 1, 2, 3, 4. So we can say rejected cakes is going to be 4 out of 13. Or 4 over 13. Right, so if we go looking at the marks for this question, our first mark comes from getting 3%, which is 12. Our second mark is for our maximum and minimum values of 412 and 388. And then our last mark is for our correct fraction of 4 over 13. Right, so that's everything for question one. Nothing kind of in the mark scheme to be aware of for that one. Nope, nothing there. So we'll go on to question 2. Right, so we're on to question 2. We have Jennifer's planning to go on a 4-night city break. So remember, it's always a good idea to be figuring out what's the important parts. So the fact that it says 4 nights in bold means we're going to have to use this. The costs are shown in the table below. We have our flights are £270, accommodation is £90 per night. Spending money, she wants £450, and the insurance is going to cost £30. She earns £400 a week. She saves 1/8 of her earnings each week towards her city break. Calculate the minimum number of weeks it will take for her to save enough money. So first of all, we need to work out how much the city break is going to cost. So we know that we've got the £270 for the flights. Because it's 4 nights at £90 a night, that is going to be £360 for her accommodation. Her spending money is £450 and her insurance is going to be £30. So we can now add these up. So remember, just to check when we're adding, we're going down here first. So all the zeros means it comes to 0. 7 add 6 is 13, add the 5 is 18, add the 3 is 21, so we put the 1 and we carry the 2. So 2 add 3 is 5, add the 4 is 9, add the 2 is 11. So the total cost of her holiday is £1,110. Right, so we know as well, so she earns £400 a week and she's saving 1/8 of it. So we need to work out what 1/8 of 400 is. So 1/8 of £400. So dividing that by 8 gives us £50. So we know she can save £50 a week and she needs to save 1,110. So we're going to divide those. So we've got 1,110 divided by 50. Because there's a 0 on each, we can get rid of those. So now we're doing 111 divided by 5. So we've got 1 into 5, which is 0, remainder 1. Then we have 11 into 5, which is 2, remainder 1. And then we've got 2, remainder 1. So we have 22.2 weeks here. So therefore, it will take her, we're going to have to round up because she only gets her wages every week. Not in the middle of the week. So it'll take her 23 weeks to save for her holiday. So now what we need to do is go through this and look at where our marks come. So we get 1 mark for calculating the cost of her city break. So 1 for the 1,110. The second mark is for knowing that you are dividing by 5. And the last mark is for doing the answer, which is 23 weeks. I will note that it says in the marking scheme that you can't get the third mark if you put 22.1, because it's not 22.1, it's 22 remainder 1, which is actually 22.2. And you're also not allowed to get mark 2 if your calculation didn't involve 50. So if you found 1/8 of 400 wrong, you wouldn't get that second mark. So we're going to go on to question 3. So for question 3, we have the height and weight of 8 children aged 6 are recorded in a table below. And we have to, on the grid below, draw the scatter graph to show the data. So our first one, we've got 104 and 18. So we need to look at our scales. So we're going up in 5s, so each one is 1. And then that's easy enough. So we're going 104, and this person weighs 18. So we're going to have to make a little mark where the 104 meets the 18, which is here. The next person we've got is 107, who weighs 19 kilograms. So 107, so it's going to be 2 over here, and we're going to be going up to 19. So again, marking where the 107 meets the 19. Right, so for our third one, it's 120 and 24. So if we go along to 120 and up to 24, we get here. For our fourth person, we've got 124 and 22. So 124 and 22 is here. We've got 99 and 17. So 99 and 17 was down here. we've got 127 and 25 as our 6 point. So 127 up to 25. There we go. We've got 104 and 19. So we go along to 104 and up to 19. So there's 2 points for 104. And then we've got 130 and 24. So along to 120 and up to 24. Right, so we need to, for part B, create a line of best fit on our scatter graph. So what we're looking for is a line where we have the same number above and below our line, of course using a ruler for this, and we need to, so looking at our points, we've got these ones are quite far spread out, and then we've got quite a similar one close in here, so it's probably going to make sense to kind of try and go roughly through here so that we've got our lines, so the points are kind of equally above and below the line, and then we've got some of the points down here that will be on the line. Remember for this one that everyone's best fit line will be slightly different than anyone else's, and you're not going to get exactly the same answer as someone else. So there we go, so we've got 2 on the line, 3 above and 3 below. So that's a reasonable straight line for that one. So for part C, it is asking us to use our line of best fit to examine the height of a child who weighs 20 kilograms. So what we do, we find the weight of 20, we go all the way across here, and we find our best fit line, and that is going down to 111. So we can write and communicate our answer of 111 centimeters. So for this question, you get your first mark for part A for having 4 even, not 2, of your points correct, and your second for having all your points correct. You get your best fit line for a consistent line of best fit, and then you get a communication mark for your answer being consistent with the line of best fit. So there, because we had exactly, when we went across at 20, it was 111, so that would be the mark. So whatever your best fit line is, as long as they are consistent across there, your mark, you'd get your mark there. And your line of best fit, remember, it'll have to be kind of roughly in between, same above and below, but it might be ever so slightly different from mine. Here we go, we've got question 4. So we've got Lynn is flying an aircraft and has been told the outside temperature is 34 degrees lower than the ground temperature. The ground temperature is 6 degrees Celsius. Calculate the outside temperature and mark it on the gauge below. So we need to work out the outside temperature first. So we have got 6 degrees and we're going to have to take away 34 degrees. So when we're doing this, thinking about a number line, so if we're at 6 degrees, we're going to have to go back 34. So the way I do this is I would go through 0. So if we go to 0 degrees, I've gone back 6. So to keep going, to be able to go 34, how much further have I got to go? And I've got to go back another 28 degrees. So it's minus 28 degrees is what we've got to mark on our gauge. So when we're looking at our gauge, we need to be careful. So it says the outside is Fahrenheit and the inside is Celsius. So it's the inside we're going to have to look at. So if we look, we've got minus 20 here, we've got minus 40 here, so we've jumped 20 degrees, and we've jumped 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So 10 jumps going 20 degrees means each one is worth 2. So if we're going to minus 28, we're starting here. So we're going to go minus 22, minus 24, minus 26, and then so it's minus 28, so it's this one here, which we need to mark. So we're using a ruler, going to minus 28 from the middle, and here we go. That's where we've got to mark our gauge to. So the marks for this question, one is for getting your minus 28, so you're working for that, and then the second mark is for showing it correctly on the Celsius scale. So let's go on to question 5. Right, question 5. So we've got guests at a wedding were asked to choose their main course. 3/7 of the guests chose chicken, 1/3 of them chose beef, and the remaining guests chose the vegetarian option. We have to work out the fraction of guests that chose the vegetarian option. So we need to work out how many people chose the chicken and the beef together. So we've got 3/7. We're going to have to add the number of people who chose beef, so adding that together. So when we're adding fractions, we need a common denominator. So we're looking for the first number that is in both the 7 and the 3 times table. So if you're stuck, you can multiply these together and that will give you a new common denominator under there, which in this case is going to be 21. So looking from the numerator into the denominator, we are going to see that from 7 to 21 we've times by 3, so whatever we've done to the bottom of our fraction we have to do to the top as well. So we need to multiply the 3 by 3 as well, which gives us 9 on the top of that fraction. The other fraction, we started with 3 and we got to 21, so we've multiplied by 7, so I need to do the same to the top. So when I multiply the 1, I get 7. Now that our denominators or the bottom of our fractions are the same, we can add the numbers on the top and we get that 16 out of 21 is how many people ate the chicken and the beef. So the vegetarian option is going to be, so we've got everyone is going to be 1, or 21/21. Take away the 16/21, which gives us 5/21 for our final answer. So for our marks for this question, so out of 3, we get 1 mark for knowing that to add fractions we need a common denominator, so showing that you've got some valid way of doing a common denominator, whether it's 21 or any multiple further. For mark 2, it's for getting to the 16/21, and then our last mark is for the 5/21. Right, so let's go on to question 6 then. We have Tom thinks that the answer to the following calculation is 8.7. So we've got 27.2, take away 4.6 times 3, plus 4.7. So we've been asked, is Tom correct? And we need to use our working to justify our answer. Right, so we need to work this out, and so this kind of question is a BODMAS question. So BODMAS, we have to do brackets, order, multiplication, division, addition and subtraction. So that means we've got to do this multiplication first. So if we do 4.6 times 3, so 6 times 3 is 18, so we've got an 8, we keep our decimal there and we carry the 1. We've got 4 times 3, which is 12, add the 1, which is 13. So that question becomes, so it started off as 27.2, take away 4.6 times 3, add 4.7. But now, with that, having done the multiplication, we get 27.2, take away 13.8, add 4.7. So now we need to work this out. So working now from left to right. So we do the 27.2, take away the 13.8 to start with. So we do 2 take away 8, so we can't do 2 take away 8. So we're going to have to borrow from our 7, make it a 6, and then bring this across. So we have 12. So 12 take away 8, which is 4. Then we've got 6 take away 3, which is 3, and 2 take away 1, which is 1. So we now have 13.4 add 4.7. So we can see that our answers definitely can't be 8.7. So we can add those two together. Again, just because this is a non-calculator paper doesn't mean that we don't have to show our working. So we can just do chimney sums all over the place. It's much safer of a method than doing things in our head, just to make sure that we definitely get the right answer. So we've got 4 add 7, which is 11, so we put down the 1, carry the 1. We've got 3 add 4, which is 7, add the 1, which is 8. Remember always when you're adding and subtracting, your decimal stays in a line. And then we've got 1 add nothing, which is 1. So our answer is, for this question, in fact 18.1. So Tom was very far off, but because it said, is Tom correct? We need to write a little sentence. So we need to write, no, Tom was not correct. As using BODMAS, we get 18.1. Okay, so that's our conclusion for that one. So this is worth 2 marks. So we get 1 for showing that we know that it's BODMAS, so doing this bit first and getting there. That is our first mark. And then we get our second mark for our conclusion with the correct answer as being 18.1. Right, so getting through these, and now on to question 7. Okay, so question 7, we have Gavin is going to South America to do charity work. He changes £750 into Boliviano. We have how many Boliviano will he receive? So we need to work that out. So by changing to another currency, we need to multiply. So for part A, we are doing 750. And we're looking along here, so Bolivian is 9, so we need to multiply it by 9 to change to that currency. So 0 times 9 is 0, 5 times 9 is 45, so we put the 5 and we carry the 4. 7 times 9 is 63, add the 4 is 6,750. So he will receive 6,750 Boliviano. Apologies as well if I'm pronouncing that incorrectly. I'm doing my best. It's not a currency that I'd heard of before, so I haven't travelled to South America. So, part B, he spends 2,700 Boliviano, and then he changes the rest into Argentine pesos. How many Argentine pesos will he receive? So we've got to work out how much he's got left. So we've got 6,750, and we're going to have to take away that 2,700. So when we take that away, we've got 0 take away 0 is 0, 5 take away 0 is 5, 7 take away 7 is 0, and then we've got 6 take away 2, which is 4. So he's left with 4,050 Bolivianos, so we've got to then change that into pounds and then put that into Argentine peso. So to put it back into pounds, we're going to have to divide by 9. So we don't have a calculator because we're in our non-calculator paper, so old school methods, but they're going to work. So we are doing 4 into 9, which is 0, remainder 4. And then we're doing 40 into 9, so the closest number is 36, so that's the 4th. And we have a remainder of 4, because it's 36 up to 40. And then 45, which is the 5th, and then we've got that, 0, so we would have £450. So we then now need to change that into Argentine peso, so we need to times it by 20. So 450 times 20. So to times by 20, we're timesing by 2, and then timesing by 10. So we end up with 9,000. 45 times 2 is 90, and then we've got the 2 zeros. So 9,000 peso. So our marks for this question. First part, so for part A, you just get your mark for your answer. For part B, you get your first mark for changing it back into pounds, and then you get your second mark for getting your answer of 9,000 peso. Right, let's go on to question 8. So we have Ian buys a new sofa. The original price was £700, so that's our first important piece of information in this question. We know that the shop is having a sale with 25% off. And then when he goes to the shop, he finds there's an extra 5% off. So we need to work this out in 2 steps. We can't just work out 30% because it's an additional 5% off the sale price, not the original one. So we need to work out 75% of £700 to work out how much it was originally in the sale. So remember that it's 75% because 25% has been taken off, so 75% is what's left. So that is 3/4 of 700. So to do that, we're going to have to find what 1/4 is. So a quarter is when we divide by 4. So 700 divided by 4. So 7 goes into 4 once with 3 left over. 30 goes into 4 7 times with 2 left over. And then we've got the 5 from the 20. So therefore we've got 1/4 is £175. And from there we can multiply the 175 by 3 to get what it's going to be for the price for 75%. So 75% of that is equal to, so 5 times 3 is 15, so 5 carry the 1. 7 times 3 is 21, add the 1 is 22. 1 times 3 is 3, add the 2 is 5. So originally in the sale the sofa was £525, but then we've got an extra 5% off that. So we need to work out what 5% of £525 is. So the way to find 5%, we can start by working out 10% and then halving it. So 10% of £525. So what we're going to have to do there is move our decimal place because we've not got zeros on the end. So it is £52.50. So then when we half that, so divide it by 2, we're going to get how much 5% would be, and then we can take that away. So we've got 5 divided by 2, which is going to be 2 remainder 2 with 1 carried over. And then we're going to have 6 there for 12 divided by 2. And we've got 5 divided by 2 again, which is still 2 with 1 left over. And then 10 divided by 2, which is 5. So we have that it would be another £26.25 that would be taken off. So if we do our subtraction, so sale price is going to be the £525, take away £26.25. So again, chimney sums everywhere, because we can't, or it's easier to do it kind of this way. You can obviously do it in your head if you know you're confident. So 0 take away 5. Here we can't do, so we're going to have to go all the way to this 5 to take 1 from there. So we take 1 from the 5 and it becomes a 4, and give 1 to the 0, so the 0 becomes a 10. And we're going to take 1 from the 10 becomes a 9, and then we have the 0 on the end becoming a 10. So now we've got 10 take away 5 is 5. 9 take away 2 is 7. We have our decimal place lined up. And then once again we've got 4 take away 6, which we can't do, so we're going to have to borrow from our 2. So the 2 is going to become a 1, and the 4 becomes 14, so we get 14 take away 6, which is 8. We've had it happen again, so 1 take away 2 we can't do, so we're going to have to borrow from the 5. So the 5 becomes a 4, and then we have 11 take away 2, which is 9. And then we've got our 4, so our final sale price is £498.75. So for that question, you could have seen that 525 and you're taking away £26.25. So you could take away the 25 from the here, and then you've got £1.25 left over, and then do it that way. or this way will work as long as you're okay with carrying things here. So we've got where our marks come from. So you get 1 mark for noticing that you've got to do 2 different steps to your equation. Your second mark comes from getting the 525, and then your third mark is for your final answer. So you wouldn't get all your marks if you found 70%. So 70% would only get you, in fact, 1 of the 3 marks, rather than all 3, unfortunately. Right, so we're getting there, getting through the paper. We're going to go on to question 9 now. Okay, so we have Stephen flew to Hong Kong to start a new job. The flight included a stop in Doha. He flew from Edinburgh to Doha and then from Doha to Hong Kong. The flight from Edinburgh to Doha took 6 hours and 35 minutes. The flight from Doha to Hong Kong took 7 hours and 20 minutes. And we're told that Hong Kong is 8 hours ahead of Edinburgh, and Stephen's plane took off from Edinburgh at 9:15 a.m. local time, and he landed in Hong Kong at 8:50 local time in the morning, and we need to figure out how long he stopped in Doha. So when we're doing this, I kind of want to visualize it as a kind of timeline. So at one end we've got Edinburgh, and at the other we have Hong Kong. And then kind of in the middle with the stop off we have Doha. So we need to work out what happened along the way. So we know Edinburgh was at 9:15 a.m. We also know that Hong Kong local time was 8:50 a.m. but we need to work out kind of what that is in terms of Edinburgh time. So we have 8:50 a.m. and because Hong Kong is 8 hours ahead, that means we've got to subtract those 8 hours, so we get 00:50 a.m. So now Stephen's trip to Doha took him 6 hours and 35 minutes. So when we add the 35 minutes, we end up with 9:50, and then add our 6 hours, so we get 9:50, 10:50, 11:50, 12:50, 1:50, 2:50, 3:50. So arrives 3:50. So from there, and that's going to be PM, we then need to work backwards from our Hong Kong flight. So that took 7 hours and 20 minutes. So going back 7 hours and 20 minutes. So we're going back from 10 to 1 in the morning. That's 7 hours 20 minutes. So go back the 20 minutes and it gets us to midnight. And then going back our 7 hours, we get 11:30, 10:30, 9:30, 8:30, 7:30, 6:30, 5:30. So we get 5:30 p.m. So that's the total time. So if they arrive at 3:50 and leave at 5:30, then it is 1 hour 40 minutes stopped in Doha. Right, so you get 1 mark for knowing how to deal with the flight time. So being able to work with and figure out when you arrive in Doha. You get 1 for knowing to deal with the fact that there's a time difference, and then your third mark is for the 1 hour and 40 minutes. Okay, so on to question 10. Right, so we have David sat a class test. His results are shown in the table below. Paper 1, there were 35 marks available and they achieved 80%. And for paper 2, 65 marks available and achieved 60%. So we have to calculate the numbers of marks achieved in paper 1 and then work out the overall percentage for the assessment or the test. So for part A, the number of marks for paper 1. So for that we're going to have to find 80% of 35. So to do that, easiest way is probably to find 20% of 35, which is the same as dividing it by 5, because there are 5 20s and 100, which gives us 7. So 80% is 7 times 4, which is 28. Right, so for part B, his overall percentage for the test. So this assessment in this case would be out of 100. So if we work out the mark for the second test, so we've got 60% of 65. So again, 20% of 65 is going to be 65 divided by 5, which is going to be 13. And then we times that by 3 to get our 60%, so we get 39. So total score, we add those two together, so it's 28 plus 39, which is 67. So our percentage is 67%. That works in this case because the total marks for the assessment are out of 100, so it would be 67%. This one, each one's only worth 1 mark, so it's 1 mark for getting 28 marks, and the second mark for part B for the 67%. Let's go on to question 11. Right, so we have a ribbon is to be placed around the outside of a love heart cake shown below. The top of the cake is made from the shape of an isosceles triangle with 2 semicircles. So we have our triangle here, and then a semicircle and another semicircle. It needs to be the length of the perimeter of the top of the cake plus an extra 2.8 centimeters. Calculate the length of ribbon needed. So we will need to find this 34 and that 34 there. So our total length of ribbon is going to have to be those two. So 34 add 34 plus that 2.8 that we need, the extra. And then we also have a semicircle and another semicircle. So 2 semicircles make a whole circle. And we know that the area of a circle is pi times diameter. So the diameter is going to be 20 for that one, because each of them, it's 40 for the whole thing, so each is going to be 20. So that comes from the fact that circumference is pi times diameter. So we need to do 3.14 times 20. So we times it by 10 first, so that's the same as 31.4 times 2. Because when we multiply by 10, we move everything up one place and replace values, so the 3 becomes 30. So when we're doing this, 4 times 2 is 8, 1 times 2 is 2, and 3 times 2 is 6. So we have 34 add 34, add 2.8, add 62.8. So in this case we can do it as a big chimney sum if we want to. I would combine, so we end up with 68 with the two 34s, add 2.8, add 62.8. So 0 add 8 add 8 is 16, so put the 6, carry the 1. 8 add 2 is 10, add the 2 is 12, add the 1 is 13. 6 and 6 is 12, add the 1 is 13, so we get length of ribbon would be 133.6 centimeters. So for this question, where do our marks come from? Our marks come from the first mark for knowing how to find the perimeter, so knowing that it's the 2 sides plus the circumference of that circle. Our second mark is for calculating the 62.8, And then our final mark is for calculating the total, including the 2.8. Right, so we're getting there. Question 11. Not too many left to go, I promise. So on to question 12. Right, so question 12. A helicopter flew from Aberdeen Airport to transport workers to Oil Rig 1 and then continued on to Oil Rig 2. It flew 82 kilometres on a bearing of 042 degrees to Oil Rig 1, and then it flew 46 kilometres on a bearing of 194 to Oil Rig 2. Construct a scale drawing to illustrate the journey using a scale that 1 centimetre is 10 kilometres. They've got additional diagrams if you need it. We get told it returns to the airport, and we need to use the scale drawing to determine the distance and bearing of the airport from Oil Rig 2. So before we do our actual scale drawing, which I'm going to apologise for now, I've made like a little video of me physically doing that because I can't obviously show you a ruler and a protractor on here. So it might not be the best because it's the first time I've tried it. But before we can do that, we need to work out our scales. So we know that we have to go 82 kilometres. So 82 kilometres, if we know that 1 centimetre is 10 kilometres, we can just divide it. So on our diagram it's going to have to be 8.2 centimetres. And then 46 kilometres is going to have to be 4.6 centimetres. So here we go. We have to draw our thing, so we move our protractor down, so it's right at the bottom of our north line. Our bearing is 042, so we go round on our protractor to 42, make a wee mark. Our protractor can come out of the way, and then we line up our ruler with the bottom of the north and the mark we've got, and we're going to have to draw a line that is 8.2 centimetres long. Again, apologies here for the kind of perspective that we've got, it's a bit off. And now what we need to do is draw our north line, so we have our north, we draw it again. Apologies again that this goes off the screen a little. I wasn't aware when I was doing it. I just am now. So now our next one is on a bearing of 194. So there we go, so I'm moving it so we can actually see the north a little. There we go, so you can see that that's what I've done. I've drawn that other north, and then I think I was waiting for it to come into focus. There we go, our north. So that's our first bit from Oil Rig 1 to Oil Rig 2. So now if we go on to drawing our connection, I couldn't unfortunately get it from a directly up angle, so there is a slight kind of incline, so it doesn't look quite right. So 194, so if we mark the 180 here, so we've put it directly on the bottom of where our Oil Rig 1 is going to be. We mark 180, we go round, make sure that that lines up with our 0, and then we're going around 14 more because it's 14 past 180 to 194. So here we have to line up a ruler with our mark and draw 4.6 centimetres. I started trying to draw it that way and realised that it wasn't going to work. So then I had to turn my ruler around. Right, so starting at the 0, we're going to line it up and go 4.6 centimetres. So there we go, start at 0. Ruler moved a bit, so I moved it back again, and the ruler wasn't quite in the right place. This is why I would suggest trying to do these with a pencil, but I know we have to do them with an exam with a pen, so we're okay. So we've got to 4.6, and that is where Oil Rig 2 is. And our first oil rig was there. So yep, there's Oil Rig 2. Apologies for my kind of bad edit there for putting my second video on, but we're going on to part B. So we have to use the scale drawing to determine the distance and the bearing of the airport from Oil Rig 1. So if we join it up, that's what we're doing, right? So joined up the origin or the airport to the oil rig there, so we can see that we get the distance which is going to be 4.6 centimeters, which is equal to 46 kilometers. I'm drawing my north, and we need to work out the bearing. So we can see that the bearing is past 180, so we've got 180. And then we've gone 67 past. So you can see there at 67, remember you're going from 0. And that's that. So if we add those together, we get that it is a bearing of 247 degrees. Right. So marks for this question. You get your first mark for part A, 4. The 8.2 and 4.6. Your mark 2 is for the first bearing drawn correctly, plus or minus 1 degrees, and the 8.2 centimeters, plus or minus 0.1 centimeters. And then your third mark for part A is for the correct bearing of 194 degrees, plus or minus 1, and the 4.6 centimeters, plus or minus 0.1 centimeters. And then for part B, as long as your bearing is consistent and your distance is consistent with your drawing, you will get those 2 marks. On to question 13. Okay, so question 13. We have a lawn is to be created with the shape of an isosceles triangle with the dimensions shown, and we need to calculate the area of the lawn. So we know that for a triangle, area is a half base times height. But our height is, if we all remember, this distance there. So we don't actually have the height of our triangle, but we do, because when we have an isosceles triangle, if we create our height, we know that it's at right angles. So we've got a triangle that's 6 and that's 10, and we're missing our third side, our height. So we're going to have to use Pythagoras, because it's a right angle triangle, to work out our height of our triangle. So the height is one of the shorter sides of the triangle, so we're going to be subtracting here. So we have a squared is equal to c squared take away b squared. C squared is always our hypotenuse, or our biggest number, so we have 10 squared take away 6 squared. So we have 100 take away 36, which is 64. So A is the square root of 64, which is 8 centimeters. Right, so that's our height of our triangle. So a half base times height, so a half. Our base, the full triangle now is what we're looking at, which is 12, and the height is 8. So when we're doing this, it doesn't matter which order we multiply in. So we can do a half of 12 and then times that by 8, or we can do a half of 8 and then times that by 12, or we can do 12 times 8 and then do half of that. The order really doesn't matter when we multiply. If we think about it, 1 times 2 is the same as 2 times 1, so the order doesn't make a difference. So if we do half of 12 is 6, and then 6 times 8 is 48 meters squared. And I just realised that I wrote centimeters over here, and it should in fact be meters. Just showing that teachers are human beings too, like you guys. We make mistakes sometimes. But always be careful. So that's something actually to take notice of, because quite often you don't get the marks in applications without your units. So it's something to make sure that you go back over at the end of the paper to check for your units. Right, so marks for this question though. We have our first mark is for knowing that to find the height you need to do 10 squared take away 6 squared. And then you get 1 for knowing that it is 8. And then your final answer for your 48 square meters. And I want to make you guys aware that if you had just done a half of 12 times 10, that would be awarded no marks, because it's not for you're not showing that you understand that it's base times height, or for identifying that it's a Pythagoras question. Okay, so you should always be looking out, if there's a triangle, think Pythagoras. Okay, almost, like definitely now almost there. Question 14 coming up. Right, so we have Michael runs a stall at the school fair. His game requires 2 spinners to be spun and allowed to come to rest. The spinners are shown below. The numbers on which the spinners come to rest are multiplied together. You win a prize if the multiplication is less than 5. Calculate the probability of winning a prize. So the way I would consider doing this is kind of in a probability table. So if we've got spinner 1 and we have spinner 2. So if spinner 1 we go across the way, and spinner 2 we can work down the way. So for spinner 2 we have 0, 1, 2, 3, 4, 5 and 6. And for spinner 1 we have 1, 2, 3, 4 and 5. So we can work out all our possible kind of combinations and then figure out how many give us an answer that is less than 5 and how many give us an answer that's more than 5, and then we can work out our probability of winning a prize. Apologies for not using a ruler here. It's just a little bit easier for me not to. But in your exam you will have one, so you can use one. It's just easier for me not to in this case because I'm using an iPad and it becomes somewhat difficult when using a ruler on an iPad. Right, so when we multiply 0 times 1, so this whole row is going to be zeros because 0 times anything is 0. 1 times 1, 1, 1 times 2, so this row is just going to be the numbers themselves. This is going to be them doubled, so we've got 2, 4, 6, 8, 10. Then tripled, so we've got 3, 6, 9, 12 and 15. So as you can see it's going up in our times tables. So 4, 8, 12, 16 and 20. 5, 10, 15, 20, 25 and 6, 12, 18, 24, 30. So we have to look for which values are less than 5. So in our first row we've got all of our values that are less than 5, so there's a total of 5 in that one. In our second row we have our first 4 are less than 5. So then in our second row we've got 2 that are less than 5, and then our next ones have only got 1. So we have 4 there, 2, 1 and 1. So altogether that gives us 13. So we have 35 options altogether because there's 7 options on spinner 2 and 5 options on spinner 1. So that means our probability or our chance of winning a prize is 13 in 35. So we get 1 mark here for realizing that there are 35 options, 1 for our 13, and then 1 for expressing it as 13 out of 35. So for this one it says in the marking scheme you don't get it for doing it as a ratio, it has to be a fraction. But other than that there's nothing there that's overly worrying in the marking scheme for you. Okay, so on to our last question, which is question 15. Here we go. We have a ramp to allow wheelchair access to a school has the dimensions shown below. The maximum gradient allowed for the ramp with a horizontal distance of 4 meters is 1 over 14. Does the gradient of this ramp meet the regulations? Use your working to justify your answer. So on our formula sheet we know that gradient is our vertical over horizontal, well, vertical distance over horizontal distance. Okay, so our vertical distance is vertical up and down the way. if you struggle to remember, think about the horizon, and the horizon's along the way, so is horizontal. So we have 25 centimeters there, and our horizontal is 4 meters. But our units need to be the same, so it is in fact 400. So we need to figure out how many 25s there are in 400, because there are 4 25s in 100, and then there are 4 100s, so it is 16 and 1. So that's dividing those both by 25. So 25 divided by 25 is 1, and 400 divided by 25 is 16. So we have 1 and 16, so now we need to justify our answer. So it is safe as 1 over 16 is less than 1 over 14. This is the case because obviously splitting something into 14 bits, the bits are going to be bigger than if you split it into 16 bits. Right, so our marks here are first one for changing and realizing that we have to have it either both in meters or both in centimeters. And then we get 1 for stating the gradient. So 1 in 16. Actually, 25 over 400 gets you the mark as well. You don't need to simplify at that point. Our third mark is for stating yes, because the 1 over 16 is less than 1 over 14. So thank you very much for watching this. Hopefully you've made it to this point. If this has been helpful, please leave a comment or like the video. The other thing you can do is share it amongst other people you know that are doing the course. The reason I do this is not because it's a money-making venture, because you'll see there are no ads. I just do it to kind of help people try and pass their maths courses, because I'm a teacher, that's what our job is. Right, so thanks again, and hopefully that's been helpful.